All right. What's good, everybody? Welcome to my live stream today. We're going to do a total review on equations and systems of equations. And I'm going to go over the three different solution types. So you're going to want to stick around for the whole entire video. All right. So when we're talking about solving equations, guys, I'm going to break this down into four key steps. All right. So step one, we're going to check to see if we need to distribute. Step two, we're going to simplify by combining our like terms. And then step three, what we want to do is move the variables to one side of the equation and the numbers with no variables to the other side of the equation. And then step four, we want to solve. So this is typically how teach how to solve like multi-step equations, two-step equations. So once we start simplifying this equation, we're going to get 3w plus 4 is equal to 3w plus 5. All right. And when I go to combine my variables, I'm going to notice something very interesting. They're going to cancel out. So when they cancel out, all we're left with are these two terms. So now we're saying to ourselves that 4 is equal to 5. And we know that that is not true. So when we have an equation where the variables cancel out, or we have a statement that is not true, this would be an example of no solution. So that means we cannot solve for the variable. There is no answer that is going to fit for this equation. So that's the first type of solution that we're talking about today, guys. No solution. All right. So we're going to go on to our second problem now. And in our second problem, we are going to actually have to distribute. All right. So we're on the second type of solution. And in this solution, first thing we want to do with the problem is check to see if we have to distribute. And we do. So once we distribute on this left-hand side, we're going to have and then once we distribute the second side, we're going to have 5x minus 10 minus 3x. So just remember, guys, very common mistake that I go over. This 3x is not inside the parentheses, so we're not going to distribute 5 to 3x. We will not multiply. Just make sure that you remember that and you don't make that mistake because it sometimes can happen. So at this step here, I'm going to want to clean up the equation by combining my like terms. So I have 7x plus 30 on one side. On the other side, we're going to have 2x minus 10. Now, when we start combining, this is what we're going to have. And just understand, we could get the same answer taking different steps. So if you wanted to subtract 7x from itself and also subtract it from 2x, we could definitely do that. But I wanted to keep my x positive, so this is why I subtracted 2x. Now at this step, guys, we distributed, we simplified both sides by combining like terms. Now we're starting to move things from one side to the other. And another thing that we have to move is our constant, right? So that our constants could be on one side, variables on the other. So once we do this, we'll have 5x is equal to negative 40. So in this problem, our variable does not cancel out. So that means we will have a solution. And the solution to this problem is x is equal to negative 8. So what type of solution is this? This is a one solution type of problem or equation. So that means when we solve this equation, there's only one number that is going to make this a true statement, right? Only one number could solve this equation. So far we went over no solution. We went over one solution. Now we're going to go into our third term. And if you guys have any questions, drop it on in the chat box for us. Definitely appreciate you guys for watching with us. And we're going to also ask that you smash the like button for us so that other people could see our show and, could share with other people. Thank you. All right, so the last type of solution we're going to talk about for when we're solving equations. So our last problem they give us is going to look something like this. All right, so we go through step one. We know that we have to distribute, but just make sure when you distribute, you do not do this subtraction here. This is a trick. We're not paying any attention to that. We're going to distribute first. So 2w minus 8w plus 6 is equal to 6 minus 6w. We distributed. Step two, we're going to now simplify. So we're going to clean up our like terms on the same side. So now this is what we're left with. And I'm going to combine my constants, bring them on the same side. And what I notice is that what we have on one side of the equation is the same thing on the other side. So what does this mean in terms of solutions? This means that I'm sorry. So this is infinitely many solutions or infinite solutions. You can use either or statement. Just understand that this equation is equal to each other. So whether we substitute 0, 1, 2, 1,000, 10, 15, 20, any number we substitute in for W for our variable, it's always going to give us the same answer on both sides of the equation. It's always going to be equal to each other. So that's why we say infinitely many solutions, because there's more than one answer. Okay. So I hope you guys have been enjoying this review so far. What we're going to do now, I'm going to switch over to systems of equations. And with the systems of equations, we're going to solve the equations using the substitution and the elimination method. And I'm going to show you guys what the graph should look like. So this is going to be the bulk of our live session for today. So problem number one, this is what they give us. And then matter of fact, let's keep two different colors for today. Okay, so this is the first system of equations. Equation number one, equation number two. So the best way to solve this is to use the substitution method because they already solved for the variable, right? They already solved. So when I go in and I substitute x plus 5 for y, this is what my equation is going to look like. And now I'm going to solve for my x variable. But the issue is when we take care of this right here, x's cancel out and we're left with 5 is equal to 2. So we know that this is not a true statement, right? Exactly. So what this means is that for this system of equations, there is no solution. And I want to show you guys exactly what that looks like on the graph. So on the graph, we've got the X and Y axis. We're basically going to have two lines, right? And those two lines are never going to, oops, it's not that one's not showing too good. It's never going to intersect. So they're basically going to run parallel to each other. So if they asked you, right, to match the graph, you would look for a graph that the lines do not intersect. They don't cross each other. They're just running together parallel. Whether they're like this, they're both up and down, or they both run left to right. They will not intersect. So that's our first problem when we're talking about systems of equations. Okay. So that's our first solution when there's no solution. Now we're going to move on to the second type of solution when we're talking about systems of equations and its graph. All right. So let's write this problem down. Okay. So when we look at this, guys, we notice that the x is based, they're both in standard form and our variables are lined up. So what I'm going to do, I'm going to go ahead and I'm going to multiply this second equation by 2 so that I could cancel out my y's. So when I multiply the second equation by 2, right, let's just put this out there, rewrite the first equation. We're now going to have 2x minus 2y is equal to negative 4. Just remember that we're multiplying each term by 2. So as a result, we're now going to combine the equations. Our y's cancel out, and we're left with 5x is equal to, let me make sure, was it negative? Oops. This was a -1, so I wrote the problem down wrong. Okay, okay, I see what I did. Yep. So this was -1. That changes this to -2, so I made a small mistake. So now it's correct. So now we have 5x is equal to -10. Once I solve for my x, I'm going to get x is equal to -2. So now with this being said, we're going to take our x and figure out what y is. So now I substitute -2 for x. And when I solve, we're going to get -y is equal to +1. But just remember, guys, don't forget this very special tip. I see students make this mistake all the time. When a variable is by itself like this, it cannot be negative. So we're going to divide both the variable and our constant by -1. That's going to make this variable positive, and now that +1 turns negative. So now we have an x and a y. So we're saying that at the point -2, -1, this is where this line is going to intersect. And before I show you guys the graph, I'm going to go back and I'm going to use a different method to get the same exact answer. So we're going to focus on using the substitution method. Because what I notice, students normally, they're very good at one of the methods. So we're just going to make sure we touch both of them so we can help everybody and as much people as possible. So let's say I wanted to do substitution. So I'm going to focus on this second equation because the variables are both by themselves. So I'm going to have, let me just make sure, I'm just going to add y to both sides. So x is equal to +y minus 1. So when I look in this first equation, anywhere I see x, I'm going to substitute it with this. So let's see how this works out. So we substitute, put it in parentheses, rewrite the rest of the equation, and now we're just going to solve like a regular equation, okay? 3y minus 3 plus 2y is equal to -8. Once we clean this up, we have 5y minus 3 is equal to -8. Add 3 on both sides. We're going to get 5y is equal to -5. And once we divide, we will get y is equal to -1, which is the same value here. So just understand that whether we use the elimination method, substitution method, once our steps are correct, guys, we will get the right answer. And after using this substitution method to get y, we would do the same thing. We'll pick either equation 1 or 2, plug -1 in for y, solve for x. So what should this graph look like? So when we have one solution, right? So we have our x and our y axis. What happen is on our graph, we're going to have two lines that are going to intersect. So let's focus on this point. This is the point where they're going to intersect, that ordered pair. So let's just say that's like right here, -2, -1. So this would be the point of intersection, and only that one solution would be an answer for both of these systems of equations. Meaning that when we plug in -2 and -1 for both x and y, in the first equation, it will be equal to -8. And in the second equation, it will be equal to -1. So this is a system of equations, one solution. All right, so let's go over to our last problem. And in the last problem today, we're going to talk about the last type of solution when we're working with systems of equations. All right. So let's see, what's this problem? And with this last problem, I want to show you guys a very big trick that's going to save you a lot of time. And I hope you guys utilize this trick because it's so helpful. All right, and let's get the second equation. Okay, so let's focus right here. So yes, this is the, we solved for y where we could use a substitution method, but just understand that this is in the same form, y is equal to mx plus b. So what I'm going to do is I'm going to switch this from standard form into this same slope-intercept form. So when I do that, right, we subtract 6x from both sides, we're going to get negative 3y is equal to negative 6x plus 12. Divide by negative 3. Divide by negative 3. We could put it all over one fraction. I just separate it, make it a little bit more easier to see. All right? Y is equal to positive 2x minus 4. So if you notice, right, they're in slope-intercept form. So they both have the same slope and the same y-intercept. What does that mean? It means it's the same exact line when we go to graph, right? It will be the same exact line. But before I show you the graph, let's backtrack. Let's back all the way back up to the beginning of the problem, right? Let's back it all up. What if we didn't notice that? What is another way that we could solve the same exact problem? And let's just make sure I write this down right, because you guys know, if you watch my videos, I be writing the problem down wrong sometimes. Okay, so what we could do in this problem is we could switch this from slope-intercept form to standard form. So let's say I subtract 2x on both sides. We would have negative 2x plus y is equal to negative 4, and I'll rewrite that second equation right under. So what I'm focusing on right now is y. I noticed that one y is negative, one is positive. So if I could multiply this first equation by 3, let's multiply by 3, right? We're using the elimination process. What we're going to get now, I'm going to write it right under this one. We're going to get negative 6x plus 3y is equal to negative 12. So once we now combine, everything cancels out, and we could say that 0 is equal to 0, which is a true statement, right? Right. So hopefully you guys saw this trick and you understand what I'm saying. Now we're going to talk about the graph, because this is essentially the same exact line. So when we go to the graph, right, we're only going to have one line on it because it's the same line. So what does that mean with the solutions? It means that any point on this line, or any coordinate, I should say, is going to be a solution. And the way that we define that, we're going to use the word infinite solutions, because more than one answer will satisfy the system of equations, okay? So thank you guys so much for joining me today. I'm Professor Peters. We're talking about systems of equations and equations, the 3 different types of solutions. We hope you enjoyed our live video today. Smash the like button on the way out for us, and we're going to upload this to our regular videos right after we're done with the live stream. Thank you guys so much for joining me today.